Hey everybody, I am going to do an explainer in 7 minutes of this long Substack that I just did to kind of illustrate to you the ideas, okay? So I'm going to take us to the moon. First I'm going to have Siri do something. Hey Siri, would you set an alarm for 8 minutes? Thank you. Okay, 8 minutes. Let's go to the moon. Whoa. It's the dark side of the moon. Forgot. I just want to show you the moon real quick. Oops, no. Oh. Okay, we're at the dark side of the moon. There's the moon. Okay, but we'll go back to the dark side. Okay, so first thing is we will do a virtual display so you can see my Mac. Hey, look at that. All right, and then I go down here and I do split screen. Okay, and it's going to go right here. Yeah. Right, and then it's going to go right there. It's a little easier for me. All right, so then we're going to move some stuff around here. I'm going to put this right there. We're going to start with that one right there. Let's make that a little larger. All right, we'll make it a little smaller and a little larger. How about that? We'll do both. Okay, I'm gonna put it right there. We're gonna go back a little further, right? And we're gonna discuss these two papers. Okay, social media and mental health, generative AI at work. All right, and social media and mental health paper is about a rollout of Facebook at college campuses. Mark Zuckerberg and his crew targeted different schools at different points in time as part of a marketing strategy to kind of generate buzz. But as it turns out, the rollout of Facebook was selecting on campuses where baseline mental health was worse. So like the Harvard, Brown, MIT, Columbia, Dartmouth schools have students with lower baseline mental health prior to Facebook's entry than the later ones, the MTSUs, the Baylor, the University of Texas and Tennessee and all these others, whoever it was, University of Florida. The last ones have higher baseline mental health. And I think that is going to be a clue as to why, well, look at that, he just knew. He knew I was going to do that. And I think that's going to be a clue, okay, whoops, as to why this coefficient here, 2A fixed effects, is lower than the robust ones, right? So then what I'm going to do is I am going to open, I have to go back to my slides. And kind of walk you through just a second. I got a robot out there. I got so many robots in this house. It is not even funny. So, he wants to come in here. He's not allowed in here. He gets stuck under stuff. So each of these regression coefficients with two-way fixed effects, like let's say we're doing that one right there, the -2 one, right? That's the -2 one. What is that -2 one equal to? Right? Well, it is a weighted average over every timing group's own relative to. And these are diff and diffs. All right? This is no assumptions at all. These are diff and diff calculations for every single group relative to their comparison group, which in 2A fixed effects is under differential timing is going to be everybody, right? So you got that. And this is like the relative time period. So it'd be like -2 compared to baseline, -2 compared to baseline. And the weights are going to sum to 1. They're going to sum to 1, right? So it's going to be a positively weighted average over all the diffs and diffs. But this one, all right, is the contamination. What this is all of the other estimated coefficients, in the model, all right, that aren't the -2. So this is like -2, but that might be like -3, -4, -5. It will be the sum of however many other coefficients you have estimated. So if we're estimating -2, all right, that's the omitted group. It goes, that one is going to be a weighted, so that one's going to be a weighted average over all timing groups -2 plus 1, 2, 3, 4, 5, 6, 7, 8, 9 other diff and diffs. 9 other diff and diffs in the model, all right, times each of them a weighted average over a weight that, look at this, sums to 0. Now, the only way a weight can sum to 0 is if sometimes it's positive and sometimes it's negative. And then this last one is a diff and diff associated with the dropped period. All right, so I'm going to skip that. We're going to go down here and just look, all right, at what happens when you start assuming stuff. So when you assume parallel trends, diff and diffs do what? They become average treated on the treated. Cohort average treated on the treated, right? So all that it does with parallel trends is turn in all the diff and diffs into average treatment effects. But this just means that whatever that diff and diff number was, it's equal to the sum of a bunch of treatment effects. You only want this one. You don't want this one, all right? Then we're going to assume no anticipation. Well, what is no anticipation going to do? Well, let's look at -2. All right, we're wanting that one. The truth is, under no anticipation, the truth is that the coefficient should be 0 plus a weighted average over 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them. But look. Oh, a cat just came in. Look. That one under no anticipation is a 0. That one is a 0, 0, 0, 0, 0. So that means it's going to be -2 plus 0, 0, 0, 0, 0, 6 zeros. Immediately get canceled out with no anticipation. But no anticipation does not cancel these out. All right? So some of them get canceled out, and this one will also get canceled out under no anticipation, because if you are dropping that period, all right, if you're dropping that period, then it's a pre-treatment, it's a baseline. Under no anticipation, its treatment effect is a 0. So we lose that, and we lose, depending on how big the event study is, we're going to lose some, but we'll still have some of the post-treatment event study coefficients in there. All right. So the last one is called, with two-way fixed effects, you need treatment effect homogeneity profile. And that's what I want to look at now. Treatment effect homogeneity profile. So what I did for illustrating, treatment effect homogeneity profile is I go to Google Sheets. And I want to show you what I did in the Substack. And that's Kitty Cat over there just tearing something up. So I believe it was this one. All right, so here we go. This is a cell. Oh, who is that? This is a cell of heterogeneous treatment effect profiles, because group 1986 gets treated in 1986, and thereafter their dynamics grow by 10. Group 1992 gets treated in 92, and after that its treatment effects grow by 8. And in 98, they get treated in 98. Their treatment effects grow by 98. Each of the coefficients, target parameter, sorry, that's my robot in the background. Each of the treatment effect coefficients is trying to average over all the relative time period numbers. So like, for instance, this one, it's averaging over here, here, and here. And that's why 10 plus 8 plus 6 equals 18, but 24 divided by 3 is an 8. But once we get down here, right, because, you know, you can't, like, I'm doing the feasible stuff. So, you know, I'm just cutting these out. But here it's starting to drop out. We're losing, if we're not able to get, just imagine it didn't go there. Just imagine that was not there, all right? So we would just only be working with something that ended in 03, right? Well, then it drops out. It's not sample selection, but it drops out. And so when it does drop out, it's only going to be averaging over the first two groups because they're the only ones that have treatment effects that go 6 periods if this data in 04 doesn't even exist. And then this one is the last one. All right, that's treatment effect heterogeneity profile. And then this one is treatment effect homogeneity profile, right? And look what treatment effect homogeneity profile is. 10 to 180, 10 to 180, 10 to 120, 10 to 120, 10 to 120, 10 to 60, 10 to 60, 10 to 60, 10 to 60. They're all the same, right? They're all the same. When they are all the same, all right, the second row cancels out. All right, so look, here we have, here's what we have. We have 2 periods. I've got this example here. I've got 2 periods, 2 groups. One group gets treated in the first period, one group gets treated in the second period. And we're going to estimate coefficients on -2 and 0. So that would be this one and this one. Okay. Actually, it's going to be -2 and the base. Yeah, -2. Yeah, -2, 0. And we're going to drop -1 and 1. We're going to be dropping a post period. That's going to be a problem. And a pre-period, right? Okay. Now, this is what that mu coefficient equals. Now, under parallel trends, all of these become cohort ATTs, right? But with heterogeneity, they could be anything, right? They can be anything. Under unbounded heterogeneity, they can be anything. So, if we assume parallel trends, all the diff and diffs become cohort ATTs. If we assume no anticipation, watch what happens. See, that's the relative time period. So that's now a 0. As is that one, because that's what we're estimating and that's what we dropped. So those go away. I don't have a good way to delete that, but wonder if I could. Hey, there you go. There you go. I do have a good way to delete it. Got to be sure to not save this though. So those now went to 0. That would have been cooler if it was black, but whatever. Those are gone. Under no anticipation, they're gone. Now, this does not necessarily, this does not necessarily sum to 0. Watch. Okay, so 1/2 times 5 is 2.5. 1/2 times 2 is 1. 2.5 minus 1 is 1.5. So, it's still not gone until you can assume treatment effect homogeneity profile, which would be this. All right, and that would mean that everybody in the 0 period has the same treatment effect, regardless if they're group 1 or if they're group 2. Right? 1/2 times 5 minus 1/2 times 5 is 0. All right? Okay, so the question becomes, under what conditions would the treatment effects be the same for every group at every time period? All right. And there's 2 ways that it could happen. One is you just don't have much heterogeneity in the data anyway. All right. That would be one way it happens. This is one of the things that you kind of get from the potential outcomes, which is under potential outcomes, you're sort of trained to believe that, hey Siri, how much time is left on the timer? I guarantee there's no more timer. You guys saw me set that timer, right? That means thank you. Must be that. Thank you, Siri. Hey, Siri, go away. Go away. All right. So I'm gonna wrap this up. 2 ways that you can have this cancel out. First of all, not much heterogeneity, in which case that right there will just be the same number. That's one way to do it. And we're now in 2024 so trained to be treatment effect agnostics, like we basically no longer have models that we use to think about what treatment effects can and cannot be, that we sort of embrace as a default that the treatment effects can be anything. Or the rollout is random. And if the rollout is random, it is independent of the potential outcomes. And if it is independent of the potential outcomes, the distribution of the potential outcomes will be the same across all event groups. And if it is the same across all event groups, it means that the treatment effects are the same across all treatment groups. Well, Mark Zuckerberg targeted certain schools non-randomly. He went after elite schools, and those elite schools had lower baseline mental health. And he shows in the paper that the effect sizes are different depending on whether or not a person is close to being mentally ill already. All right? So you have kind of some a priori reasons to think that it's not random. And not only is it not random, it's possible that there could be some heterogeneity, in which case two-way fixed effects will be biased, all right? Versus the generative AI rollout. So the generative AI rollout here, they did a staggered introduction of a generative AI conversational assistant using 5,179 customer service agents. Access to the tool increases productivity as measured by issues resolved per hour, all right? But the question is, well, how are they choosing who gets who gets it? And they don't really say. I don't think they said, but they do it really quickly. All right, they do it really quickly, and one thing to just be thinking about is they probably don't know a lot about the effect of generative AI on different workers. It's these guys' papers where they actually try to figure it out, and they actually do find evidence in the paper for heterogeneous treatment effects by certain baseline characteristics. Like, are you a low skill customer service agent? Big effects for you, small effects if you're good. Have you been there very long? If you're brand new, big effects for you. If you've been there a long time, no effects. All right. So he's coming in here. He's stuck. All right. Well, let me wrap this up. So if it's random, and you do have heterogeneity, if it's random, then what we've seen is that two-way fixed effects will basically have, it's not that there's no negative weighting, it's just that probably the treatment effects are the same for each group. And so the weights that sum to zero are just going to cancel out the bias, and two-way fixed effects probably is pretty similar. So again, we kind of see a lot of the stuff that you sort of learned about from Emmons and others, which is knowing something about your it's raining, so it'll be kind of loud. Knowing something about your treatment assignment mechanism allows you to select these estimators a little bit more. If you literally do not have any information about the treatment assignment mechanism in a staggered rollout, you have to go with that robust diff and diff. If you're not willing to make any statements whatsoever about how those treatments were being assigned to groups of units with respect to their potential outcomes, then you just really need to do all the diff and diffs, or find the one diff and diff that you kind of believe in, or that you know the best. They're all unbiased and they're very similar versions of parallel trends. Otherwise, if you do know that it was random, use two-way fixed effects because it'll be more powered. higher powered and uses more variation in the data. And that, my friends, is everything. And this is Mount Hood, and it's raining today. Rain's kind of coming at an angle. What's weird is that up there, I would think that the rain would mean it's coming from a dark cloud up there, but look, that's the dark cloud. But you know what? I actually don't know how rain works. So that very well may not even be how rain works, but look in the distance. It's beautiful. All right, you guys, have a great day. Bye.